Hi guys, today we are going to see about volumetric analysis. What is the principle of volumetric analysis? For example, we are taking two solutions. Any two solutions we are taking. Okay, this is a first solution and this is second solution. And these two solutions are reacting with each other. These two solutions are reacting with each other and we got the products. So the product of volume and normality of first solution, volume and normality of first solution is equal to product of volume and normality of the second solution, and this is the basic principle of the volumetric analysis. V1 into N1, which is equal to V2 into N2. So V1 means volume of first solution and N1 means normality of the first solution, which is equal to volume and normality of the second solution. This is the basic principle of volumetric analysis. So the next one is titration. What does mean by titration? The same thing. Two solutions are reacting with each other and that process is detected by experimentally. Two solutions are reacting with each other and that process detected experimentally, and that is known as titration. Okay, and that is known as titration. In this two solution, what does mean by standard solution? Standard solution means what? The solution whose concentration is already known, and that is known as standard solution. Any solution we are taking in the beaker, for example, any solution is present in this beaker and this solution concentration we already know. Which solution concentration is already known, and that solution is known as standard solution. Okay, and next one, what does mean by endpoint? Endpoint means the end and completion of the reaction is experimentally detected, and that is known as endpoint. For example, in the burette we are taking any one solution and in the conical flask we are taking another one solution. There's two solutions are reacting with each other. The completion of the reaction will be shown. So that point is known as completion, end of the reaction, and that point is known as endpoint. Okay, then neutral point. What does mean by neutral point? We are taking two solution. No, if one solution is acid and another solution is base, for example, it will be a acid base reaction, means the end point is known as neutral point. Okay, it will be a acid base solution, means the end of the point is known as neutral point. Next, indicator. What does it mean by indicator? Indicator is a substance. By a suitable color change, it is added in the reaction. Okay, indicator is divided into three types. One is acid base indicator, another one is precipitation indicator, another one is redox indicator. Three types of indicators are present. Indicator is a substance. By a suitable color, it will be added to the solution. It will give the end of the reaction, and this indicator is divided into three types: acid base indicator, precipitation indicator, and redox indicator. So in the volumetric analysis, we are going to do one sum. 20 ml of oxalic acid requires 19.8 ml of 0.095 N. N means normality of sodium hydroxide. Calculate the weight of crystalline oxalic acid present in 500 milliliter. So we have to write what are all the values we already know. 20 ml of oxalic acid. Oxalic acid is the first solution here and sodium hydroxide is the second solution. So this is the first solution and this is the second solution. So we already know 20 ml of oxalic acid. So first solution volume we already know. Like that, second solution volume ml, milliliter. Second solution volume also we already know. First solution normality we don't know. Second solution normality we already know. N means normality. So 0.095 normality we already know. From this we have to calculate the weight of crystalline oxalic acid present in 500 milliliter. Okay. Now what are all the values we know? Write that one. Okay. Volume of, what is the first solution? Oxalic acid. Volume of oxalic acid V1, which is equal to how much? 20 ml. Normality of oxalic acid, we don't know. N1 we don't know, so write question mark. Next one, volume of second solution is here what? Sodium hydroxide. Volume of sodium hydroxide V2 is equal to what volume here? Second solution volume 19.8 ml. Third one is normality of sodium hydroxide N2. Sodium hydroxide normality is 0.095 and they already given. So here what value we have to find out now? Normality of oxalic acid. So what is the formula of volumetric analysis? V1N1, which is equal to V2N2. This is the main formula. So what are the values? We already know. V1 know, V2 known and N2 known. N1 we don't know. So known value you have to write here. V1 20 into N1 we don't know. So write N1, which is equal to V2 is 19.8 into N2 is 0.095. Here we have to find out N1. So this 20 will become here. So N1, which is equal to 19.8 into 0.095 divided by 20. So what is the answer we got here? 0.094, and totally this is the normality of the first solution. What is the first solution? Oxalic acid normality we already find out. But in the question what they ask, calculate the weight of crystalline oxalic acid which is present in 500 milliliter. We have to calculate the weight of the oxalic acid in 500 milliliter. Before that 1 liter we have to calculate. Okay. 1000 milliliter, which is equal to 1 liter. If we find out 1 liter, afterwards from that we have to find out 500 milliliter. Okay. So first we have to find out weight of oxalic acid in 1 liter. Okay. So write the equation. Weight of oxalic acid in 1 liter, which is equal to, what is the formula? Normality into equivalent weight. This is the formula. Weight we have to calculate means what is the formula? Normality into equivalent weight. Weight of crystalline oxalic acid, how we can calculate? From the equivalent weight into normality. What is the normality we find out here? 0.094, and equivalent weight of oxalic acid is 63. This is for 1 liter, but 1 liter means 1000 milliliter. Okay, 1 liter means 1000 milliliter, but they ask in the question what? 500 milliliter they ask. So half only we needed. So we have to divide this. We have to divide this. For 500 milliliter we have to divide this. So the answer is 2.961 gram. So this is the weight of the crystalline oxalic acid. Again I will repeat. What are the values we know? Volume of first solution we know, so we have to return. Volume of second solution we return here, and the normality we return. This is the basic formula we return here. Then we find out normality of oxalic acid. Why we find out normality of oxalic acid? Because we have to find out the weight of the oxalic acid which is present in, they ask for 500 milliliter, but we find out for 1000 milliliter, which is mean by 1 liter. The formula is equivalent weight into normality. Then we write the equivalent weight of the oxalic acid and the normality of the oxalic acid, which is divided by 2. Then we got the answer. This is the answer.